Right, so yeah, we'll obviously kickstart. So first and foremost, obviously, thanks to everyone joining us this evening for the next sort of Golang live webinar. You're joining us tonight from probably Jakub will be the same from the UK, so it's probably the hottest day in the UK calendar so far this year. So it's quite warm this side of the world. So yeah, so tonight Jakub, a principal Golang engineer, will be joining us. He'll be doing a talk on building and releasing Go apps with GoReleaser. So as always with these webinars, they're really informative. We like to ask, feel free to ask as many questions throughout the webinar itself. One thing, there's probably 3 or 4 different breaks during the webinar where people can ask questions, but ask them during the webinar, and then at the breaks we will obviously get to the questions themselves. So yeah, no matter how big or small, yeah, feel free to just ping them in the chat or the question box. So I'll obviously hand it over to the main man himself, Jakub, who will be delivering the talk. So yeah, thanks very much for joining us, Jakub. I'll leave it to you.
Hello everyone. Hello, Shaun. So can you hear me properly, right? Yeah, screen is visible.
Yeah,
okay,
yeah.
So welcome everyone. So as Shaun mentioned, let's take it as informal as possible. I see this as a so-called brown bag session. So frequently at work, we have a meeting every week or every 2 weeks with engineers and discussing different topics related to technologies, either technologies that we are dealing at day-to-day basis or technologies in general. So today I will show a little story that actually the main character is the GoReleaser, which is the Go tool for releasing applications. And how this tool actually helped to save a lot of thousands of euros for the one small company. So we will go through the couple of steps where it was released to and started to be used by the one company. And then I will demo a couple of cases that is basically I prepare based on these original cases. Okay, so let's start. So as I mentioned, so the agenda for today, I prepared more or less something like introduction to GoReleaser, and then I will introduce the business case with description how this GoReleaser and how Go application was introduced to a company. And then I mentioned a couple of release patterns from very basic up to the pattern that we are leveraging the CI pipeline. And of course, all these patterns will be pictured with few simple examples how actually this GoReleaser tool was used. So basically, this is official logo of the GoReleaser. It was the it's very popular project, mainly for automating the releasing Go applications, but not only to create releases as the packages, but as well it fits very nice into CI and CD, so-called pipeline, continuous integration and continuous delivery, especially because it automates a lot of tasks that otherwise could be glued together using, for example, Bash script or PowerShell or, for example, Python. And of course, very popular, the make files for Go developers and Go repositories. So basically, a main idea of the GoReleaser is to create the declarative description of steps that allows us to take the binary, take the source code, run tests, and then basically create the binary release and do something with the release. So we could create, for example, a binary that is snapshot. So we are not dealing with creating tags, creating particular versions of our software. This is very handy in situation that we need to, for example, create quickly binary and test this either locally or quickly in our test virtual machine or share with colleague. So this is like a quick and dirty approach, but in many places it's very useful. Another approach is, of course, to use so-called tags. So when we are creating a release, it means we are creating a tag for our software. Either we can build locally using the GoReleaser this particular version of software and then distribute in a variety of ways among the colleagues or among the, for example, customers or internal or external customers. And apart from this, of course, we can send these tags and create releases in GitHub, in GitLab. And apart from releasing to this Git repositories, we can do a plethora of different stuff with our binaries. So one of those that I listed here on this slide is we can, for example, take this binary, create the tarball, and upload to S3. If S3, for example, involves some workflow in our company. Another very popular is the Artifactory. So if we are not dealing with some publicly available software, and we don't have, for example, the GitHub Enterprise internally, and we have Artifactory, we can create these packages and send to Artifactory. And then from Artifactory, continuous integration pipeline, for example, can pull or directly configure the installation of, let's say, of the operating system that our colleagues use. So, for example, we are using GoReleaser. GoReleaser releases the RPM version of our software, put it into this Artifactory, and then when in this particular the development, for example, shop, we are using the CentOS or Red Hat or Debian, we can configure directly our repositories to point to this Artifactory, and the entire process of releasing our packages is nicely closed using the GoReleaser and Artifactory. Apart from this, we can create as well the OS packages. So be this, of course, when we create the binary, we can specify that this particular binary works for Linux, works for Windows, works for macOS, and many other architectures as well. But the easy way of running this software, we can always SCP to a remote machine or take it, put it into the path, and then start using this. But in the more and the normal, not I would say sophisticated, normal environment, we should basically create the operating system specific package that wraps in RPM or in Debian or any other package manager our created binary by GoReleaser, and then upload to configured repository from where actually this package is installed on the machine, be this laptop, be this, for example, local personal desktop, or somewhere, for example, servers. Of course, it involves a lot of the security checks on the way, but in the simplest way, we are creating this OS package RPM, uploading to either Artifactory and any other package repository. And from there, after scanning, this package is packaged in the specific operating system versions are installed by engineers or by some automatic system. So that's like a quick introduction what kind of tool we are dealing with. Yeah. So, okay, so the next, I would like to introduce the business case. I don't know, Shaun, are there any questions?
Does anyone have any questions first and foremost before we move into like the business case on the theoretical side that Jakub just spoke about? It's not a problem if not, but I just wondered if anyone had any questions first and foremost on that small theory part that Jakub just talked us through. It doesn't look like it. Okay. Jakub, so we can just move on to the business case scenario.
Okay, so let's have a look at this business case. Let's name this company Rusted Pipe. This business case is based on the real scenario. Of course, the name of the company is changed, and a couple of facts along the way as well. But the main actually introduction and the idea of saving money and leveraging Go itself and the GoReleaser is taken from the real scenario. So the Rusted Pipe company, it's the semi-public company. It means that the state has some shares and there is as well the partially privately owned. So this company basically deals with utilities management and mainly deals with the servicing and checking different pipes. So mainly it's the sewer systems or the water pipes. And because of this, they introduced many years ago the modern GIS system, which is the Geographical Information System. It's basically systems that electronically allow to create the maps and then monitor different part of this utilities directly on maps. So the next very important the business of this company is creating the digital maps. If someone, for example, requests certain maps of the area, for example, some company that is doing maintenance of the gas pipes or electricity, and they need to have the information if, for example, during the digging, they would damage something, they need to have first, basically they need to do research first and then figure out if there is any danger or not. And because of this changing environment, new pipes, for example, are created or new damages are done in certain places. So they need to, this company needs to collect this data and mark this into database, which is reflected directly on these maps. So they have the huge GIS server and couple actually of servers that process this data, and they serve the digital maps for the different purposes. So monitoring and creating different products for external companies, because these maps can be sold as well. And the main point actually is data collection, and data collection, it was the main trigger for this entire process of automation that I will be talking today. Because at certain point, they started sending engineers to the different areas, and with the special GPS devices, they were marking certain location, and they were sending this data back to the server. And later on, so maybe I will tell in details in the next slide. So the main characters in this story, they are basically three personas from the business perspective. And when we are actually creating the software specs, we are always dealing with personas. So we have the GIS officer. So this person is responsible for receiving the data from this system. Basically, he logs in, getting the data that were previously sent by the surveyors to the backend system. Now we have GIS developer that will be brought into the picture later on, and we have IT operation person who is responsible for managing the backend systems and the virtual machines and different part of the operating or IT of the entire company. Plus we have so-called business units. So this is like a broad company structure. In short, we have business units that they started processing this data, GIS data, using a variety of tools. But they need to have this data already processed and cleaned. And this process was not automated at the very beginning. And it was caused a lot of problems due to delays, due to problems with accuracy. That was the introduced bugs when people were manually processing this data. So basically, this IT department was responsible for sending data to servers, then was provisioning machines with different software for these business units. So the entire distribution of software at the very beginning that started helping with the processing this data was done in Python, and it was done by external consulting company. It's basically, it helped a little bit with processing, but there were certain bottlenecks that basically are mainly organizational one, because the consulting company was charging a lot of money, and sometimes the main company was not happy with their services. And basically, they started thinking how we can actually handle this business case how we can handle this this situation that we basically paying a lot of money and we don't have a lot of return from this in terms of the saving time and speed of processing. So it was first actually the case was that a couple of engineers, they were technology savvy, and they basically they were doing some automation with Python at the beginning, and they started looking into automating certain cases. So it was idea of apart from having 1 or 2 engineers, as far as I remember, that would be in charge of automating this process. It was the first idea of bringing actually a developer which would be in charge of the automating these different various processes. And this basically process, it was more or less like ETL. So we were extracting data, transferring them, and then loading to different systems. So at the very beginning, that was the big problem with this data processing department, due to the fact that majority of people, they were basically processing this data manually. So it was the main bottleneck, the entire process. And the main reason why we started actually thinking about introducing the development. The development was introduced exactly at this at this point. So basically collected data was loaded to the server. Then we were running these engineers were running some automated processes. First in Python, they started later on using Go. And basically this helped a lot of this data processing department with, first of all, reducing number of errors and speeding up the entire process. And at this point, I would like to say about and show the first actually like the pattern that this engineer started using, and why actually this one. So imagine that we have company that they don't have any development inside. They don't have servers. They don't have development machines. They have basically engineers that they work on their workstations. There is no programming involved, no Python installed, no any development. And right now we have situation that someone will need to start automating system. The question is, he gets the laptop, this person or two, and he creates piece of software. Now the question is how we are releasing the software, how in hands of the multiple departments we will basically handle this piece of simple software, as I will show in a second, that actually can save a lot of hours of manual data processing. So this was the broad at the very beginning, moved from Python to Go. That was the first step. And due to the fact that basically we could generate the binary for multiple operating systems, because majority of people were using Windows, but there was the couple of people using the Ubuntu machines and Mac OSs as well. So it was automatically the GoReleaser, and Go itself was the winning solution from the basically distributing of software and generating binary for this particular operating systems without the burden of managing packages on the machines of engineers. So let me right now introduce this simple application. This is actually the application that I wrote some time ago, but this is not this exactly, just to illustrate this small process that was introduced. This is basically a very small application that takes the piece of the log file that is coming from one server, does some processing, outputs CSV file, and this CSV file is taken manually by this engineer that sits in the middle and then uploads to another system. So this was the first step of automating this entire process. Even though people were involved, the time of processing of the CSV files was the matter of seconds instead of matter of minutes and sometimes hours when people started introducing certain issues. So how this application works. So let me show here the command line interface. So we have built this application right now. We have a couple of make targets. And this application basically, let me clear the screen. We have simple tool that when we run the H, basically we need to pass two parameters, what file is coming in, what file is coming out. This application, because it's the very simple binary, can be embedded and can be, for example, embedded into the Python process or run by shell. Doesn't matter. But for example, we are in the inside, we are and we are specifying, for example, out data CSV, and this was the fraction of a second to process only a couple of logs. But this couple of logs that I will show in a second were processed manually. So we have this application. We have output file is basically something like this. Three columns, that's it. We don't even need to know what it means. This is cleaned and it has to be sent basically to the server. And the problem was at the very beginning that it worked, right? And this binary was sent by email, that was sent by sharing the, for example, folder to other coworkers. Of course, it helped with processing, but it was not scalable when they started introducing new versions of this software, because it was getting more and more sophisticated. This example here is a very simple one. So the problem that we started actually introducing is the problem that people started reporting bugs. And when they started reporting bugs to engineers didn't know, or they were spending a lot of time trying to figure out, okay, when this software was released. And they started tracking changes, what kind of change could introduce particular issues. And it was the first actually step that they started thinking about introducing the basically Git to the company, because this company was not using Git so at all, because it was not development. So we have this situation that this is right now, this process. We have GoReleaser, we have releasing application, single binary, and we are basically shipping to the folder. Next step, because of a lot of these problems arose, was actually to start leveraging Git in this company. And the company went into the option of using the external enterprise version just for security reasons and mainly for privacy as well. So how this application changed? From the releasing point of view, so this is the version of this Arts T tool. And let me show how it works releasing. And then I will show quickly how it looks like. Let me make this font larger here. Okay. So now we are at the stage that we want to generate snapshots of our applications. So in order to do so, we, at the very beginning, we are running, initializing the GoReleaser, that GoReleaser creates the configuration file, and then this configuration file can be tweaked according to our needs. So let's have a look how our GoReleaser file looks like here. And it's basically consists the simple file at this moment of couple of parts. So it's basically part before. It means what kind of command we should run before attempting of building this particular release. Then we have the part that describes our builds. We have the environmental variables, CG enabled, for example, instead of writing from the command. Then we are specifying what kind of operating systems we need to build this particular application for. So we could have only Windows, only Linux, only Darwin. And the matter right now to generate this binary for particular the operating system is just add one line here in this GoReleaser configuration file. We need to specify where is our main file. In our case, it's in the CMD directory. Then we are generating the so-called archives. Automatically, we are generating checksums as well. And then there is a couple of options for the changelog and how it works. So when we look into the makefile and go to the end, I created here the make targets for that actually wraps the GoReleaser command. So we have GoReleaser build -- snapshot and remove destination folder that was created by previous run. So let me escape. So when we run right now, our releaser takes this YAML description of the steps, what should happen, and basically automatically creates releases for different operating system. Let's have a look. The automatically default is the destination directory is created by GoReleaser, and we have basically argt is I named this local for this example. So we have built for Darwin, we have for Linux, we have for Windows exe files, and basically at this moment it's a matter of one click in the running one make target, and GoReleaser takes our application, generates automatically the binaries for these three operating systems. Yeah, so this was this stage that developers and automators started using the Git and GoReleaser to actually speed up this entire process. And the next stage, this actually I showed this demo built locally. And the next stage was actually started introducing so-called tags to build. So we can create, for example, a release locally. If we decided that our software reached a certain point, we can create a release and then distribute this release in the same way like before. But at this stage, we know what kind of version particular, let's say, engineer is running. So if they are reporting bugs, it's much easier to figure out where something, for example, went wrong and where we created some issues. So how it works with tags. So what is the difference? This is different version of this application. It's just differ with our GoReleaser file. Only one difference is right now that we added here the release information with the GitHub name and some information. And we are marking here, hey, we are disabling or not disabling, it depends, for example, how we want to do this, uploading this particular release to GitHub or not. So if we want to release this, we need to figure out make release. We are creating release right now. And now we have the certain errors because we created some issues here. Let me have a look. Uploading release. Okay, so the main idea actually was to generate releases first locally on our computer and then upload these releases to our Git repository. I just got some error here. Okay, so anyway, we have here generated our binaries for as before. Now, apart from this, we are generating releases of the particular tag that is introduced in this repository. And the situation on the Git side looks like this, that we have right now the tags. We have this GoReleaser. This is exactly this file that we were using on my laptop. And we are generating releases here in Git. So now for Linux, for Darwin, these files that we have on our laptop automatically are uploaded and created release in Git. And this was the huge improvement because either, let's say, IT person from Git could get these files and create some distribution in the virtual environments for business people, or these business people could, for example, upload themselves and then install on their laptops. So it was huge step forward in terms of the entire cycle of writing software, releasing, and putting this into hands of our customers, because in this case, the internal customers for developers were basically business units, internal customers. Okay, so the most sophisticated step that actually is the most popular. Yeah.
We've had a question from the audience. So one of the questions, one of the problems encountered when doing this was the incompatibility of GLIBC versions between different distributions. GoReleaser is using GILBC version of the host it runs on. Is that correct?
Yeah, could be. Yeah. Probably. I was running this like before, but now something happened. Yeah. Could be. Yeah.
Perfect.
Any other questions?
I think that's the only question so far. We'll just keep them coming as they come in.
Okay. So the next step was actually start introducing so-called continuous integration systems. That was the option to actually go with this internal server, most popular Jenkins, or to leverage some other external CI servers like Circle CI or Travis, or in this case, the company decided to leverage the GitHub Actions. So what it means that we are not building software, engineers are not building software anymore on their machines. They are creating tag. Tag is sent and creating in Git. And then Git automatically, this GitHub action automatically generates using the GoReleaser internally this binary and this release is available for as well, either for IT people to create some, let's say, distribution in VMs, or directly for business people. Another big advantage is as well to be able to automatically generate via this GitHub Actions basically the operating system packages, the RPMs and Debian packages. So in terms of Go, if we are not using any sophisticated configuration files, usually it's a matter of package this without any external, let's say, the scripts that would need to be part of the operating system package, like some pre-actions and post, for example, install actions. So let's have a look what changed in this application. So
yeah, could we just add another question?
Yeah.
So can GoReleaser be used with Docker containers?
Yes.
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 Perfect. Thank you.
Okay, so this is the final version, like a third stage of our application that is leveraging so-called this GitHub Actions. Excuse me. So what is happening? Let me change here. Yeah. Okay, maybe I will show here will be better visible. So what we need to do, basically Git allows us to create so-called actions. So be this description, like in the past, I was using mainly Travis and Jenkins a lot and Circle CI. So basically we need to create description of steps, what should happen when we, let's say, commit the certain version of software to our repository. And here in GitHub creates the GitHub workflows, and then we have YAML file that describes these different actions. So this is example of small, because these files can go very, very long and be sophisticated. So let me explain in a few words what's going on. So basically the name can be whatever. So we have name build. Now we need to specify when this build should be triggered. In our case, when we push, for example, to branch main, and when we create any tag, then we are basically creating this entire starting this entire workflow that will end up generating packages. So we are specifying, hey, let's use the Ubuntu latest, which is the Docker image that is used under the hood to run this workflow. Then we have the checkout stage. So basically this entire workflow checking out our software from our repository. We specifying what Go version we can use. We could use 1.15 or 1.14, depends on the, for example, the needs. In this case, just is the newest one, 1.16. Now we are leveraging the caching modules. So when we are building quite frequently and we are pulling, for example, dependency for Go, we don't need to basically every time spend the time and the bandwidth for pulling these dependencies. We are caching them here. Now we are specifying the steps that were included in our, at the very beginning, the makefile, which is basically we are running go mod tidy, making sure that all our dependencies are in place. And then we are running tests. And then when tests pass, we can go to the next stage, which is named GoReleaser. And GoReleaser uses the internal so-called Github Action releaser that we could leverage. So we are doing this, that we defined, hey, use GoReleaser here. And if all the steps, previous step is successful, then let's start this entire process here already internally inside the infrastructure of the GitHub, not on our local machine. So at this moment, we are offloading this manual step done by developers or DevOps people to actually this proper CI system that will be building our packages. We are specifying, hey, give me the latest version. And this is the very interesting, because if this is the arguments that we are passing to GoReleaser, we would pass them in our, let's say, CLI on our laptop. But here Go, if we won't specify GoReleaser file here, releaser uses default settings, which allow us to basically leverage the releaser to generate quickly our binary. The only one difference is that the default version of this GoReleaser have the configuration that they expect the main file in the root directory. So if we have, for example, the different setup, like I will show in a second, we will need to specify the small snippet at GoReleaser that is leveraged internally by GoReleaser Docker container here. So this is description of this entire pipeline. Apart from this pipeline, we had to add this small snippet of GoReleaser, which is right now much shorter than the previous one. So what we are doing here, we are specifying project name, the same as before. We are specifying environmental variables we can add for what kind of operating system we want to build our package, what architectures. We can specify ID, and this is very important here, that we need to specify, hey, where is the folder that holds our main, basically, entrance to our application? Where is our build? If we don't specify this, it will error, because as a default, the GoReleaser looks for the root directory. So this could be okay if we are, let's say, building library, and we have all the tests and Go files inside one root folder, and we don't have actually main. Or main is, for example, only we have project only with main directory, a couple of files, for example, and we don't have any sophisticated structure of packages. And then this is actually definition for the next step that allows us to leverage as well from the GoReleaser. They have another project which allows to basically build the operating system, different Linux packages. So this is name of the NFPMS. So if people Google, or we will send the links after this, this project can be used to build, for example, RPM or Debian packages. I was using in the past FPM. It's a very popular tool for building very sophisticated the RPM and Debian packages, actually without going into the deep descriptions of these packages. So it's as well a certain level of abstraction on top of the entire process of generating RPM packages. Now we are adding a couple of information about what will go to this RPM and Debian packages. And because we don't have any additional commands for building operating system packages, we are basically specifying, hey, build us Debian, build us RPM package, because we are dealing only with one single binary. And this single binary will be as a default deployed to user/bin. If we want to customize something, we will need to create certain scripts that here will need to go into this description and then be part of our repository. But then the most important is that GoReleaser can take care about this as well. So how it works, entire pipeline here. Okay. What tags we have? Git. Because we have specified that we want to trigger the build only on the new tag. We need to create some change, commit this change, create the new tag, because otherwise we would get an error because we won't be able to trigger the build, because build reacts only when we are pushing new tag. So for example, let's add some dummy file. Just for example. Easier. Just to make some change, I doubled the comment. When we are changing, we are changing. Now we need to basically add this makefile. Makefile is waiting, and we need to create commit. That's my setup. Okay, so we have prepared our commit. We need to commit. Not very sophisticated, this message, but anyway. So we are committing. And once we committed, right now, let's create a new tag. As far as I remember, we have 1.5 already. Git. Okay, 1.5. Let's create tag 1.6. Okay. So git tag add version. Let's do this manually. Now we need to add some message. Let's name this. Okay. I had typo. Okay, so let's do this release. Run. So now let's push everything. Okay, new tag is created, and let's jump quickly to our actions on this repository and see. So this is workflow. What is happening right now? This build is triggered because we created this tag, we pushed. So job is triggered in GitHub Actions. So the GitHub action using the GoReleaser basically generated all our artifacts required by engineers. So let's just go quickly, very quickly. We have the setup job, so it's internal stuff for then checkout is basically getting our source code. Setup go. We defined that hey, let's use 1.16 version. Then we have this step cache modules. Let's run tests. We have a couple of tests only for this package. Everything passed, so GoReleaser can actually trigger this entire job. So this is the GoReleaser action step by step. We are basically checking GitHub tokens, downloading all dependencies, and we are generating the most important here part, of course, our binary that we defined in our description. And then apart from our binaries, we are generating as well the RPMs. We are creating the Debian files. And this, when we go back to our actions, basically, we have information here. Okay, this step was successful, it's green. We generated this new tag 1.6, and our code looks like this, that here we have our new released version, 1.6. This is what commits went to this repository. And the most important, of course, is that we have our Debian RPM packages nicely generated. Yeah. So this is the basically moving the step of generating from our laptop, from local machine, done by person to actually to machine. To machine, like in our case, it was the GitHub Actions, but this is like a fully leveraged modern CI systems and continuous deployment systems that for many developers is like a bread and butter. But in many actually companies that they would like to leverage software, be this Go on any other language, but to process business processes and to automate business processes. Basically, this is huge step forward from, let's say, moving from releasing software through the email to coworkers, or to shelf order, to basically simple CI, for majority of developers, simple CI tool that automates very mundane and error-prone tasks. Of course, there is a lot of plethora of other stuff related to CI and CD pipelines, but the most important is that it doesn't need to be sophisticated in order to really speed up business processes like simple parsing files and generating input, where, for example, people could save time and the company can save money by leveraging a simple solution like, for example, like we see today. So that's it from my side.
I think we had a couple of other questions, and keep them firing away as we're going, if anyone's got any questions. But I think one of the other questions was, can GoReleaser be used inside GitHub Runner?
Inside, I don't know, to be honest. I don't know.
Okay, fair enough. There was another question, how to manage versioning using GoReleaser. Is it possible or not?
It is possible. I didn't do this. Instead of actually manually create tags, we can send and we can make GoReleaser to manage this task.
Yeah. Okay. Perfect. Thanks very much. Has anyone got any more questions at all?
I really encourage people to go to GoReleaser official webpage, there is couple of the tutorials, but actually this page is like a description what we can do with this, and this is huge. It's like more like a not big tutorial how to tackle particular problem, but plethora of use cases that we can use. And I encourage as well to go to YouTube. I not posted here the link for a couple of excellent talks that they are, some of them 2 hours long or 1 hour long, but actually going deeper into small particular part of the problem that GoReleaser solves.
Yeah. I think some people have asked to the best place to get this info and share the URL, but we will obviously send a follow-up email with stuff in and around the URL and send this presentation to attendees and stuff like that. So we'll get all the websites and URLs and information that Jakub was suggesting to everyone after the webinar, probably tomorrow.
Actually, yes. Shameless plug. I'm preparing the ebook that focuses on actually leveraging this tool chain in a couple of CI/CD pipelines. So it will be available probably by Christmas.
Nice, lovely. Has anyone got any more questions? I'll obviously give everyone 10 seconds or so to get their last questions in. Or has anyone got any final questions?
Thank you very much. This is obligatory because we were using this lovely our creature Gopher. And thanks to gopherize.me. So nice. Thank you very much.
It doesn't look like we've got any more questions actually. So so first and foremost, I'd like to obviously thank Jakub for the excellent talk. I think there was some brilliant topics covered in this around GoReleaser. We had some great questions from the audience. So first and foremost, thanks very much to Jakub for the brilliant presentation. The webinar's been recorded. It'll be available on our YouTube channel for people to watch afterwards, and we'll send over an email to everyone tomorrow around obviously the presentation itself, the YouTube link, and also some of the URLs that Jakub suggested as well. So once again, thanks so much, Jakub, for it was a brilliant talk.
Please contact me on Twitter just in case you have, if I will be able to answer questions. I'm really happy to do this.
Yeah, or obviously you mentioned on Twitter or LinkedIn or something like that. You're happy, obviously, for people to connect with you and obviously ask some questions and stuff like that. So we'll ping them both Twitter and Jakub's LinkedIn over tomorrow. So once again, final thanks so much to you. It was great to hear the talk, and
thank you very much. Thank you very much for having me, Shaun. Yeah.
Perfect. All right then, everyone. Have a great evening. Whatever you're doing, we'll speak to you all soon. Cheers. See you later.